When we talk about parabolas in terms of conic sections, we have two main types of parabolas. We have vertical parabolas. These parabolas either open up or they open down. The vertical parabolas have a form of their equation which looks very similar to vertex form. It's y equals 1 over 4p times x minus h squared plus k. Sorry, my app updated and my pen is a little weird. There we go. Now, it really is vertex form. It's just that we're replacing a with 1 over 4p. So I want you to remember that because it's going to come in handy later on. Now, we have all these weird letters in here, so we want to think about what they represent. We have HK, and HK, just like always, represents the vertex. Do you see what is wrong with my pen? This is annoying. Alright, and now we have P. And this variable P represents the distance from the directrix to the vertex and from the vertex to the focus. In just a minute I'm going to look at a graph and I will label this on that graph. And we also have a second type, and that is parabolas that are horizontal, and horizontal parabolas either open to the right or to the left. Horizontal parabolas get flipped, and so their equations are sort of flipped as well. This time we're going to be looking at an equation where x equals 1 over 4p, that part stays the same, times y minus k squared plus h. So I want you to notice how x and y switched. Well, that means k and h also switched. However, 1 over 4p still equals a. That's still going to be your stretch, except it's not going to be vertical and horizontal this time. It's going to deal with direction. And hk is still the vertex. Just because those letters switch positions in the equation doesn't mean it changes what they represent. It's still hk, the vertex. Always the coordinate pair goes x, y. P is also the same thing, the distance from the directrix to the vertex and the vertex to the focus. And in just a second, I'm going to draw a picture and we're going to look at that a little more closely. We're going to use these two equations to write equations from graphs or write equations from information. So here's an equation for a vertical parabola. If we were thinking about it in terms of vertex form, you guys could tell me which direction it opens and what the vertex is. We can also find some other information now that we know about how parabolas are part of conic sections. So we know the vertex is at the point 1, 3. We also want to try to find the focus, which is a point, remember, and the directrix, which is an equation. It's either y equals or x equals, depending on the direction of opening for your parabola. So in this case, I like to sketch a picture. That helps me figure out everything that's going on. I know that my vertex is 1, 3, so I'm just going to put a point somewhere up there. Now remember, in our equation, we said that a, that negative 1 over 16, equals 1 over 4p. And that variable p is what we need in order to find the focus and the directrix. So I'm going to use cross products and multiply these two guys so that we end up with negative 4p equals 16. So we know that p equals negative 4. Now remember, this is the distance from the directrix to the vertex and the vertex to the focus. So let's start with the focus. The vertex to the focus, I need to travel down 4. I know it's down because it's vertical, so I know that it's either up or down, and since it's negative, I have to go down. So I'm up there at 1, 3, and so the focus would be down here at about 1, negative 1, because 3 minus 4 is negative 1. Now this helps me sketch out my parabola. I know that the focus is inside the parabola, so I know it's going to open like this. And the directrix, remember, is that line that is sort of behind the parabola. And that distance is exactly the same. That's also p. So if we go backwards, we're basically going to go up 4, and we're going to get that equation. So our directrix is the equation y equals 3 plus 4, which is 7. So from this equation, we were able to identify the vertex, the focus, the directrix, and also draw a graph. When we look at this equation, this is a horizontal parabola because we have x equals. Horizontal parabolas still have all the same information about them though. Since we have it in graphing form, we can identify the vertex right away. Now remember, you need to be careful. H and k switched. So I see y plus 2, which means y minus k, so k is negative 2. Then h comes from whatever got added at the end, and in this case nothing got added at the end, so the vertex is the point 0, negative 2. We are also going to be able to find the focus and the directrix. However, we can't do that until we simplify a little bit and use that to find p. Remember that a, in this case is 1 over 24, equals 1 over 4p. So we're going to use cross products, and we're going to be able to find p. So 4p equals 24, so p equals 6. Remember, this is the distance from the directrix to the vertex, and the vertex to the focus. It always helps me to look at this on a graph. If you can do it in your head, no problems. But we know the vertex is at 0, negative 2. I'm going to put a point somewhere down there. And now I know that based on A, it's positive, so it has to open to the right. So to get my focus, I need to move to the right 6 places. So my focus is going to be way out here, and that's going to be 6 places away, which is going to be 6, and it's still along that same axis of symmetry, so negative 2. You can think about that AOS, remember it's sideways because this is a horizontal one. Now we have enough information to sketch our parabola. The focus is inside the parabola. There's a sketch of it, which means our directrix is going to be behind that parabola. Remember, the distance is the same, even though my drawing sucks. It's going to be 6 back in the other direction. So when we count back 6, we're going to be at the line x equals negative 6. When we have it in the equation, it's not too bad to find the vertex and the focus and the directrix. We're going to look at a couple examples now where we're given some of that critical information, and we're going to have to translate it into an equation. So here we're given some information about a parabola. It has a vertex of 1, 2, and a directrix of y equals 4. We need to find the equation and the focus for this parabola. To figure out which direction the parabola is, you can use the clues about the directrix, but what usually helps me is to draw it out. I'm going to sketch this parabola. I know that the vertex is 1, 2, so that's going to be about right there. And the directrix is the equation, or the line, y equals 4, so it's going to be up here. This tells me that this is a vertical parabola that opens down. Now, we can actually figure out p from this information. We know that p is the distance from the directrix to the vertex. To get from the directrix to the vertex, I have to go down 2. So let's think about our equation. It's vertical, so we're going to have y. So here we have another parabola. In this case, we know that the vertex is negative 2, 0, and the focus is at negative 5, 0. So for this one, we need to find the equation, and the other piece of missing information is the directrix. So again, I'm going to sketch it out to help me kind of visualize which direction it's opening in, what kind of parabola I have going on. So I know the vertex is at negative 2, 0, so there's that point, and I know the focus is at negative 5, 0. Remember, the focus is inside the parabola, so this tells me that I have a horizontal parabola that opens to the left. Now in our equation, that gives me some clues. I know it's going to be an x equals equation. And the first thing that we need is a, which is 1 over 4p. And we can find p by looking at our graph, the distance from the vertex to the focus. How far do you travel to get from negative 2, 0 to negative 5, 0? you go -3, and so that tells us what p is. So 1/4 times -3 is going to get us our value of a. It's going to be -1/12. I'm going to go ahead and put this in my equation. Now the only other thing I need to finish my equation is the vertex. So we're going to have y minus k. Well, in this case, k is 0, so it's just y minus 0, so squared, plus h, so minus 2. Now we have our equation, we can find our directrix. Remember, the directrix is the same distance away, but on the other side. So we need to go 3 in this direction, and we're going to end up at the directrix. So we were at -2. We moved right 3 because we're going backwards to the directrix. That means we're at 1 now. So our directrix is the equation x equals 1. Now, this time, we know the directrix and the focus. So we don't know the vertex. That's one of the things we're going to need to find. And we also need to find the equation. You can use context clues from the information that's given to you in order to figure out which direction it's opening. But again, sketching it just makes it so much easier to see what's going on. So we have the directrix at x equals -1. That's a vertical line here at -1. And we know the focus is at 3, 5, so I'm going to put that in there. Now, the vertex is halfway in between these two things. There's the vertex going to be. So we need to think about how far apart the directrix and the focus are. If I'm at -1 and I'm going to 3, I travel a total distance of 4, which means each of those smaller distances is 2. So this gives me some clues about how to find the vertex. I know that my parabola is going to open to the right, so it's horizontal. So I'm going to get my equation started before I worry too much about the vertex. X equals. Now we are going to have 1/4p as our a value, 1/4p. Now looking at our picture, p is the distance you travel from the directrix to the vertex and the vertex to the focus. So that's going to be 2. So 1/4p is going to be 1/4 times 2, which is going to be 1/8. So I'm going to fill that into my equation, times y minus k. Well, we can figure out what the vertex is based on what we already figured out. We know that the vertex is going to be along that same horizontal line with the focus. Is going to be 2 away from the directrix and 2 away from the focus. So in this case, our vertex is going to have an x value of 1. And since it's on that same horizontal line, it will have the same y value as the focus. So our vertex is at the point 1, 5. And we can fill this into our equation. We know that it's y minus k, so y minus 5 plus h plus 1. And the reason we're using that equation is because it's a horizontal parabola. In this last example, we're going to look at a vertical parabola. And this vertical parabola has a vertex of 2, 3, and it goes through the point -6, 11. So we don't have any of our special points here except the vertex. We don't have the focus or the directrix. We can get started on our equation though, because we know it's vertical, so we know it's going to be y equals. We don't know what the a value is right now, so we'll leave that blank. X minus k, x minus h, which is x minus 2 squared, plus k, so plus 3. So we want to think about that information that the point gives us. It's a point, an ordered pair, which means it gives us a clue about the value of x and the value of y. So looking at our equation, we have a place to put x and we have a place to put y. I'm going to use that equation to figure out what a is. So we have 11 equals a, because I don't know what that is, times x, -6, minus h squared plus k. We can use our basic solving skills in order to figure this out. So this says that 11 equals a times negative 8 squared plus 3. I'm going to move that 3 to the other side, so I'm going to subtract 3 from both sides. So 8 equals a times 64. Now we just need to do one other thing to find a. We just need to divide both sides by 64. So this gives us our a value of 1/8. Now I can finalize my equation. I can put this into the equation 1/8. However, we still need to identify the value of p. Remember that a is 1/4p. So 8 equals 4p, so p equals 2. This tells me the distance I need to travel from the vertex to get to the focus, and the distance that I would travel from the directrix to the vertex. I'm going to sketch this parabola out to help me figure out what's going on. Know that my vertex is at 2, 3, and it's going to open up. So to get to the focus, I need to travel up 2. So I'm at the point 2, 3. If I go up 2, I'm going to be at the point 2, 5. Now the directrix is going to be behind it, or underneath it in this case, and is going to be that same distance below. So we're going to go start at the vertex, which is 2, 3, and we're going to go down 2. If we go down 2, we're going to end up at the line y equals 1. So, given lots of different various pieces of information about parabolas, we can use these clues to help us figure out the focus and the directrix, as well as the graphing form of the equation for that parabola. It's important to just remember what those two main equations are, and then you can use sketching graphs and finding those context clues to help you figure out what the missing values are.